Hey everyone, this past week Veritasium released a very interesting video that explored why people make different decisions in the famous thought experiment known as Newcomb's problem. But in that video they missed something very important. Not every dollar is worth the same. Now, I'm not here to start beef, just adding to their video and pushing it a little bit further. So in this video, I'll quickly explain what Newcomb's problem is, discuss how Veritasium explained people's different decision making, outline the one piece that modern economists would add to the discussion, and explain why it's not just important for Newcomb's problem, but also why it's important for policy making more broadly. Because if you don't understand it, the policies you design won't be optimal. By the way, if this is your first time watching, I'm Seamus. I've spent the past decade working in Canada's public service after studying both public policy and economics. I make videos to help you better understand how public policies are made and what their impact really is. So let's get controversial. If you haven't seen the Veritasium video, I still encourage you to go check it out because it is really interesting despite the slight omission that I talk about here in this video. But if you haven't and you're not familiar with Newcomb's problem, here's a quick summary. You walk into a room with two boxes. In box A, there's always $1,000. In box B, there's either $1 million or nothing. You have two choices. You can take both boxes, box A and box B, or just box B, the mystery box. But before you entered the room, a supercomputer predicted which decision you would make. If it thought you would just take the mystery box, it put $1 million in that box. But if it thought you were going to take both boxes, it would put nothing in box B, and so there would just be the $1,000 in box A. The supercomputer has already made its decision, the money is already in the boxes. Do you take both boxes, both box A and box B, or just box B, just the mystery box, hoping for the $1 million? You can let me know in the comments if you would be a one boxer or a two boxer. The Veritasium video explains how you can reasonably get to either option and discusses how it's your perception of free will, rationality, and how to live life that impact which decision you'll make. Their video is super interesting because they're asking the question, how do you determine the probability of the supercomputer being right? Now, one of the tools that they say can help you make that decision is to use an expected utility formula. However, they then go on to show you an expected value formula rather than a true expected utility formula. That's the problem that I see as an economist that I want to address in this video. The setup is this. Your expected value from taking two boxes is the probability of the computer's prediction being right, C, times $1,000, because it correctly predicts that you're choosing two boxes, so leaves box B empty, plus the probability it got it wrong, which is 1 minus C, times the $1,001,000 that you get in that case. If you choose one box, the probability is just the probability that the computer guessed correctly times the $1 million you would get, because otherwise you get nothing if it didn't guess correctly. It's then about thinking what value of C, in other words, how confident you are that the computer will choose right, that determines if you should choose one box or two. And that if you're slightly more than 50%, that is 50.05% to be exact, confident it made the right choice, you should only choose the mystery box. But here's where I take issue with their setup. What they're looking at is what probability of the computer being correct gets us to the exact same expected dollar value. But that is not the same as what gets us to the same expected utility. And those are two different things. There's a known fact that economists call diminishing marginal utility. That is, that for every additional dollar, it improves your life a little bit less than the previous dollar. You can check out the video I did explaining utility to get some background on utility if you need a refresher. But the general principle that not all dollars are equal is actually fairly intuitive. If you were to give me $1 million, my life would improve substantially. But if you were to give a billionaire $1 million, it wouldn't impact their quality of life at all. And that's the idea behind diminishing marginal utility. So how would I go about setting up a more accurate expected utility function? Well, by replacing the value of money with the increase in utility that money gives me. And again, the goal is to find the value of C, or the probability of the supercomputer being correct, where the expected utility of one box is greater than the expected utility of two boxes. The model for diminishing returns can be represented by a logarithmic function. I will use the natural log. Empirical studies show that it is a good approximation of how more money contributes to greater utility. But because it's not a linear formula now, unlike the expected value formula that was used in the original video, where we start actually matters a lot. So we have to add our starting wealth into the formula. What we're looking at now is how much happier I am from each outcome times the likelihood of that outcome occurring. It does that by taking the utility of if that outcome occurs minus the utility that I had to begin with. Let's find out what the value of C would be needed for people of different wealth levels to choose one box. Remember, when looking at just dollar value, the answer was 50.05%. Let's look at three people: someone who has just $1,000, someone who has $1 million, and someone who already has $1 billion. The formulas are on screen if anyone feels like pulling out a calculator, but the answers in the bottom row are what you really need to pay attention to. For someone who only has $1,000, they need to be 52.64% sure that the supercomputer is right to choose one box. For someone who already has $1 million, they need to be just 50.054% sure that the supercomputer is right, while someone who already has $1 billion needs to only be 50.05% sure. In fact, the expected value answer we saw earlier is almost exactly the answer you get for someone who is already extremely wealthy. What we see is that the poorer you are, the more attractive the guaranteed $1,000 becomes. Now, the main focus of the Veritasium video is on how people come up with what their guess of C is. That is, how do people determine how likely they think that the supercomputer will be right is. And that's a very interesting topic. And probably more important than the question of how much wealth are they starting with. As you can see, it's only a couple percent difference for someone who's only got $1,000 versus someone who has $1 billion. But the fact that it matters at all points to something much bigger. In public policy, we're often evaluating decisions that have to do with money, whether it's taxes, spending, subsidies, or benefits. And just like in this thought experiment, it can be tempting just to add up all the dollars evenly to try to determine if it's a good policy or not. But economists usually try to evaluate policies in terms of their impact on utility. In other words, economists care about well-being, not just the amount of dollars. Because of diminishing marginal utility, a dollar given to someone who has very little generally improves their life a lot more than giving the same dollar to someone who is already very wealthy. And this finding itself justifies a lot of different policies. One of the most obvious examples is progressive taxation. One of the ideas that justifies progressive taxation is that someone earning $1 million can more easily give up some of their income than someone who is only earning $30,000. And so it makes sense to tax them at a higher rate than the low-income individual. The same logic also applies to policies like employment insurance, disaster relief, or food assistance. Losing a few $1,000s can be devastating when you have very little. Well, when you're very wealthy, losing that same amount can barely change your life. So if the policy goal is to maximize well-being, which it doesn't necessarily have to be, but if that is the objective of the policy, transferring money from very wealthy individuals to lower income individuals can help achieve that goal. In other words, the exact same principle that affects how people make decisions in Newcomb's problem also shapes how economists think about policies like taxes, transfer, and social policy, because they know that $1 is often more valuable to someone who has little than to someone who already has a lot. In the Veritasium video, they say about 50% of people are one-boxers and 50% of people are two-boxers. I am certain that in the sample, the people who chose one box are almost certainly more wealthy in general than the people who chose two boxes. It is not truly a random 50-50 split. But that's it for me in this video. If you enjoyed it, please like and subscribe, and I will see you in the next one.